up and smell. Wake up and smell the pheromones.
Woo! I guess it's enough dirt. I can stop now.
You know, that's an excellent example of a negative feedback loop.
Wait. If I just keep throwing dirt, what's that called?
I guess that would be called a positive feedback loop.
Right, of course, man. I get it. I understand completely. It's positive because it's good?
Well, actually, no, not at all. Positive feedback because something is telling you to continue throwing dirt. And when you decided to stop earlier because something in that brain was still functioning, that was negative feedback.
Oh.
Here, I'll try and explain it another way.
No, I don't.
If 4 enzymes are making an amino acid and the first enzyme, the supervisor, notes an excess buildup in the amino acid, he will stop the assembly line and wait for inventory to drop and then begins the line again when levels drop.
Oh, so like an on-off switch?
Kind of. The on-off switch is a better example of a signal molecule.
A signal molecule?
A signal molecule is a small molecule that is designed to fit a niche of an allosteric enzyme, a special kind of supervisatory enzyme, and it controls its shape between regulatory and active and decides whether or not the work site is functioning. That's how hormones work.
Wow, that's so cool. I know a lot about this stuff too, you know.
Oh, do you now?
Of course, in a local level loop, allosteric enzymes can do more things. The excess of a product becomes the indicator and goes to the allosteric protein, changing its shape and changing its function until the indicator leaves.
What? How? How do you know this?
And in a higher level feedback loop, the repressor sits on the DNA nucleus so that the transcription cannot happen. To make protein, it stops making products so that the lower level loops also stop working, preventing the cell from wasting energy or material.
I don't understand.
Okay, well let me explain again.
No, I understand the concept, you walnut. How did you know that?
Okay, I know a lot of things, man.
But,
Like how bacteria move. Let me explain.
never mind.
Bacteria move in relation to food, alternating between running and tumbling. Tumbles change the direction of the run, and it creates a random walk. While tumbling, the flagella rotate counterclockwise, and while running, they rotate clockwise.
Well, that's actually really interesting. I don't know much about bacteria, but they always make me think of infestations like pests. Ugh, fleas.
Don't diss the fleas, my bro. They're actually pretty rad. There are worse infestations.
I guess that's true. What about spiders? They're terrible.
Oh, dude, I could tell you some interesting things about spiders.
You know, I'd rather you not.
Do you know that spiders follow a set of 4 rules to help them survive?
Here we go. You off on another rant again.
The first step is the lockstep sequence. It's a programmed sequence that the spider follows.
What do you mean?
It tells the spider what to do in a basic level. For example, it's programmed to release the strand to the breeze. When it attaches, cinch it up and attach the near end. It walks across, paying out a second, looser strand, attaches it at both ends, and then slides into the center of that strand and drops another strand to form a Y.
God, why did I ask?
I just wanted to give you some local knowledge, man, you know, from my trusty mole brain.
Hey, I'm not dumb. I know all kinds of things about spiders, unfortunately.
Lay it on me, my dude.
Alright, fine. The second rule they follow is the if-then rules. The spider measures the angle of each radical, and if the angle is too wide, then it adds another radical.
Wow.
The third is trial and error. For example, if it sways too much in the wind, they will try adding weights. If this doesn't work, they will abandon the spot.
Wait. I can tell you what the fourth rule is. It's simulation. Spiders make a kind of sketch using temporary webbing. They carefully construct the final web and eat the original sketch.
That's right. Who knew a mole could know so much?
Yeah, I like spiders, you know. What I don't like? Wasps.
I'd be glad you're not a spider then.
What do you mean?
You can't tell me you've never heard of the parasitic Ichman wasp.
That, bro, has never entered the brain I possess.
Well, let me tell you about it. The wasp temporarily paralyzes the spider to insert an egg into its abdomen. It feeds the spider fluids for a few weeks until it induces the spider to build a platform using the webbing that's really strong. And then the larva eats the spider.
Whoa, gnarly. But there's one thing I don't got. How does one tiny larva induce the spider? Does it have superpowers or something?
No, it uses a kind of chemical.
Oh, I got this. You know, this kind of reminds me of fire ants.
Ew, no!
Did you know that there was a species of fire ant that got into the U.S. around the 1920s? Because they were not part of the natural ecosystem, their population grew at a dangerous rate.
You know something interesting about ecosystems?
Wait, let me finish.
This will be quick, I promise.
Fine.
An ecosystem is like one big feedback loop.
Is that all?
No, not even close. I have an example in case you don't get it.
Gee, thanks.
In freshwater, some fish eat algae. Then they excrete organic waste, and that is then eaten by the bacteria, who excrete inorganic materials that the algae eats. They all depend on each other with the fish as the governor.
Wow, that's so cool. But can we get back to my story, dude? Or else I'm gonna forget.
Go ahead.
Yay! Okay, so fire ants' population grew very fast, and that's not good, because they can smell... kill small animals. They infect dangerous places and houses. If only there was something to do about it.
But there is. Phorid flies.
Excuse me, dude, but the flies got me lost.
There's a family of flies that can help. Do you remember what we talked about related to spiders?
Of course, bro.
Okay, well they pretty much do something similar to the larva and eat off the head of the ant.
Wow, that'd be terrible if I were an ant.
They are. And since the flies near them become a mob, making them less of a predator, that's how they help.
A prey's response to a predator is interesting, huh?
Definitely. It's funny how it can be manipulated too.
What do you mean, bro?
Like the toxoplasma, for example. When it infects rats, they become attracted or allured by the risk of predators.
That's terrifying.
Yeah, I mean, molecular communication can get messed up pretty easily.
But it can also be really strong and do amazing things, my man. Like, dictoslim... Help me out with this word.
I'm not sure how to say it either, but, Dictyostelium discodium.
That might be right.
I'm ashamed to ask this of them all, but what is that?
It's a group of individual cells responding to a shortage of food by becoming a coordinated cellular community.
Wow, that's actually really cool. Well, I have to get back. Trash cans won't knock over themselves, you know.
Laters, my dude. What? What was I thinking about? Oh, my arm!